In recent research presented at the American Heart Association's Basic Cardiovascular Sciences Scientific Sessions 2024, scientists explored a novel approach to improving heart function in mice with heart failure with preserved ejection fraction, or HFpEF. This study sheds light on the potential benefits of increasing ketone supply to the heart. Heart failure with preserved ejection fraction is a common type of heart failure characterized by symptoms and signs of heart failure, despite a normal or near-normal left ventricle ejection fraction of 50% or higher. Unlike heart failure with reduced ejection fraction, where the heart's pumping power is 40% or less, HFpEF lacks established management plans and therapeutic strategies. This condition is becoming more prevalent due to an aging population and rising obesity rates. Despite its growing incidence, there is still no clinically effective treatment for HFpEF, making this research particularly significant. Healthy hearts require a high rate of adenosine triphosphate, or ATP, production to maintain their continuous pumping action. ATP is generated from a balanced use of glucose and fats. However, ketones, a special energy resource, can also play a crucial role. Ketones are a special energy resource, said study author Chu Violet Sun, a PhD candidate at the University of Alberta in Canada. When blood glucose levels fall, such as after prolonged fasting or strenuous exercise, the body produces ketones through a process called ketogenesis. These ketones can then be used to fuel the brain and improve the heart's pumping ability. In this study, researchers assessed the metabolic profiles of mice hearts with HFpEF. They found that these hearts had impaired ketone use and glucose oxidation rates, coupled with an increase in fatty acid oxidation. These changes balanced each other, leading to overall preserved energy production. When the researchers increased the ketone supply to the hearts of HFpEF mice, they observed a significant increase in ATP production. Specifically, ATP production from ketones and glucose oxidation increased from 15% to 28%, with preserved pumping ability. This is crucial because this increase in ketone use by the heart did not cause any interference with glucose or fat use, Sun explained. Elevated ketone oxidation did not further aggravate the disrupted metabolic profile of the heart in HFpEF, making it a promising area for future research. The findings from this study could pave the way for new treatments for HFpEF. By identifying key proteins involved in cardiac energy metabolism, researchers hope to discover druggable targets for future medications. The American Heart Association's 2024 Heart Disease and Stroke Statistics Report highlights the global prevalence of heart failure, with an estimated 56.2 million people affected in 2019. This number likely underrepresents the true rate of heart failure due to data and diagnostic gaps in low-resource regions. The next steps involve investigating the precise role of ketone use by the heart in HFpEF and assessing whether increasing ketone supply could optimize heart energy production and improve cardiac function. In summary, increasing ketone supply to the heart in mice with HFpEF has shown promising results in enhancing ATP production and preserving heart function. This research offers hope for developing effective treatments for HFpEF, a condition that currently lacks clinically proven therapies. As the prevalence of HFpEF continues to rise, driven by an aging population and increasing obesity rates, these findings could lead to significant advancements in heart failure management and treatment.